This is Physical Science 1, Chapter 2, Part 2 on Science, Technology, and Society. In this portion of the video lecture, we will be discussing developing technologies. Remember, science and engineering go hand in hand. Scientists have the knowledge of the scientific principles. They work in the research laboratories, so they get that knowledge base. Then, once we know things, we can start to apply them. So engineers bring the principles and the research to the people through technology. So how do we find solutions to technical problems? Well, very similar to the scientific method, the first thing that we need to do is identify the problem that we're trying to solve. So you're clearly defining the problem, doing a little bit of background research to find out all you can. Perhaps in this case, the engineer would work side by side with the scientist to get some of that content, knowledge, background that they would need to solve their technical problem. Once we've identified the problem, now we can start the solution. So this is when the engineer, in most cases, will start to brainstorm, maybe perhaps start to include others in the work, taking a look at maybe perhaps developing models or data tables, charts, or graphs so we can kind of visualize what the problem is. So remember, the scientist is the knowledge finder and the engineer is the science applier. So an engineer is a researcher who is responsible for bringing technology to the consumer, which is you and I. Technological problems, once they have a solution, can often create a demand for new scientific knowledge. So science and technology work hand in hand. Each subject progresses the other. The more we learn about science, the more we can apply that in technology. And the more that we solve through technology, that may open up some new questions for scientists. So science and technology work hand in hand. For the engineer, in order to develop new technologies, the engineer must build what's called a prototype. The Latin root proto means first or beginning. So a prototype is a full-scale model that's used to test a new product. So we talk about models in science as being a way for people to understand how something is visualized and how something is represented. So a prototype is like the first model that's made of the new technology that you are trying to develop. And in order to make that technology, we have to have manufacturing in place to do that. So a pilot plant is developed. A pilot plant is a smaller version of the assembly line, the real production equipment that will closely model manufacturing conditions. So for example, in the image here, if we are going to develop a new cell phone that perhaps is flexible and bendable and won't break, a prototype would be developed using materials that the engineer would believe that would be durable enough for the consumer. And then a small pilot plant would be developed to show how we would put this new prototype together. Now, engineers cannot just make any type of technology they want. In some cases, there are constraints. Constraints are design restrictions for products from outside factors. So these are kind of like rules of their technology development. In some cases, for example, the flexible smartphone, we can't make the flexible smartphone out of materials that will bend or break under intense heat or pressure. You don't want your bendable cell phone, if you happen to leave it in your car on a summer day, to melt all over your seat. So there are some types of those kinds of constraints that restrict the design of the prototype and of the final product. Often for prototype testing, you need to see how these perform. Often in cases of a prototype that's not a physical prototype that one could touch, computer simulations are often used. So they imitate the process to collect data, or they can test a product or procedure given a certain rules or constraints. Now, just like scientists, engineers also have to be moral and ethical and have standards. So engineers have to comply with laws and regulations. So local communities, states, and federal governments have laws and regulations regarding manufacturing processes of technology, the actual products of technology themselves, and the buildings that those technologies are manufactured in. And those laws and regulations don't just have to do necessarily with what is being made and who is making it. Manufacturing process, making sure that there's no toxic byproducts that are made throughout the manufacturing of said technology, that the building is structurally safe to hold all of the equipment that is going to be making this technology or housing the technology. Engineers will get a patent so they can keep the rules for manufacturing their product and keep the ingredients list, if you will, kind of private and exclusive to them. So a patent is a legal document granted by the government that gives an inventor and an engineer the exclusive right to make, use, and sell an invention for a specific number of years. Patents do expire, and so it is the responsibility of the inventor or the engineer to resubmit a patent if they so wish after theirs expires, because once that patent expires, then the inventor or the engineer does not have the exclusive right to make, use, or sell those products anymore. So somebody else can take that and perhaps make it better. And in lots of cases, that's how technology is developed. Engineers will have their patent, they write out their patent, and they allow kind of the engineering community, the scientific community, to kind of have their go at it while they develop something new that they will then, again, have the exclusive right to make and use, given that they put a patent on their new product. This has been Physical Science 1, Chapter 2, Part 2 on Science, Technology, and Society.